Hey kids, Mr. Murray here, Mr. Murray's Mathland. Today we are taking a look at evaluating a definite integral. So integrating this but not using plus c, that would be for an indefinite integral. And what tells you it's a definite integral are these two numbers here called the limits of integration. So we're integrating this expression from 0 to 4. And I have the graph of this function that we're going to integrate right here so we can interpret our result and get a sense of what it actually means. But a definite integral has a numeric value. You're not just finding a function, a solution to a differential equation. You're finding your final answer will be a number here. Okay, so let's just jump right into it. First, let's integrate this expression. So the antiderivative of 3x squared becomes x to the third. We divide by 3. The coefficient is 1. This is really 12x to the 1/2. So when I add 1 to that exponent, it becomes x to the 3/2. Dividing by 3/2, aka multiplying by 2/3, will give you minus 8 as the coefficient. And then, of course, the constant would be minus 2x. And we do not need plus c because I'm going to be plugging in these limits of integration and finding their difference. And therefore, the c would cancel out, when you do c minus c. So unnecessary with the plus c when you do a definite integral. Okay, first we plug in the upper limit. It's always the upper minus the bottom here. So the upper minus the bottom. So that will be 4 cubed minus 8 times 4 to the 3/2 minus 2 times 4. And then I'm going to do minus plugging in 0. Minus plugging in 0. Well, plugging in 0 in this case will work out pretty well because 0 cubed is 0 minus 8x is 0 minus 2 times 0. It's all a big fat 0 on the inside there. If you want to write 0 3 times, fine, but that should work out pretty well. It's just going to leave you with minus 0. So let's just simplify this first part. 4 cubed, that is 64, minus 8 times 4 to the 3/2. 8 to the 4 to the 3/2 would be the square root of 4, which is 2, and 2 cubed is 8. Minus 2 times 4, which is 8. So here we go. We get 64 minus 64 minus 8 leaves us with negative 8. And so this final value is negative 8. Now what does it represent? The definite integral gives you the value, the signed area, the cumulative area between the curve and the x-axis between 0 and 4 over the interval 0 to 4. And it's negative because between 0 and 4, on this graph here we can see, here's 0, here's 4. The area right off the bat here, the area between 0 and whatever this x-intercept is, it's not that area is negative, but it's below the x-axis, so that has a negative value. And from that x-intercept onto 4, we gain back some of that. That has an area, and that would have a positive value. But you can see that there's more below the x-axis than there is above the x-axis. So that sort of represents a cumulative loss in whatever this function might represent in the future. So more is below the x-axis than is above, and that's what that negative 8 represents, is that 8 units of area are below the x-axis compared to above. And there is a way to check this with a calculator, so I'll show you that right now. Very handy to know this. So let me bring this function up here. And I put it in, there's two different ways to do it, of course. I put it in y1 here. So if I go to the graph, I've already adjusted the windows to kind of match the way it looked on paper here. Nice graph here. But in the calculate menu, which is the second trace. So second trace, and you'll notice here, item 7 is the integral symbol. That's pretty much the only button we haven't used at this point. So second trace, 7, and now it asks you for the lower limit. What's the lower limit? We're starting at 0. You hit enter. What's the upper limit? We're going to 4. The interval was 0 to 4. Hit enter. And now look what it's doing. It's shading the area as it's calculating it. It looks just like it did on paper. And you do see that there's a slight differential. It's giving you negative 8.00057. To 3 decimal places, that's still negative 8. But the calculator is not doing calculus per se. It's really just doing a lot of little rectangles, essentially, and adding it up. So that's why it's not getting exactly negative 8. But hey, we know we did it correctly when you see that and you compare. So it's a nice check of your work here. And the other way to calculate this is on the home screen. Suppose you don't want to graph it. No problem. You go to the Math menu, Math, and item 9 is Function Integrate. So Math 9, and it brings up this beautiful integral, just like it looks on paper. So 0 to 4. And then on the inside, you can type that integrand, the expression there. Or again, if you have it stored in Y1, I can use the alpha trace Y1 shortcut. And it's with respect to X. And so it's going to give you that numeric value of negative. And again, very similar. It doesn't give you exactly negative 8, but close enough to give you confidence in your algebraic solution. So there we go. That's the idea of a definite integral and how to check it with a calculator. So if you have any questions or troubleshooting with your device, just let me know. Otherwise, hang in there and keep working hard, kids.